Yeah, I think so.
Okay, stream is turning on. Okay, so last time, how was the stream delay? Like when I would talk about something and show it, how long till you could see it? Was it a problem?
I don't think it was a problem. It was like a few seconds. Uh,
Okay. And then how'd you like it?
I think I liked it. Seemed fine. Seemed fun.
Okay. So I had one more thing to say, and then I thought that we should try making some trees. So the thing is about different types of diagrams or organizing things. Let me get a text. So okay, so there's this like hierarchy of diagrams, and I identify the main differences as how many parents and children are allowed. So normally if you write like a book, every paragraph can only have one parent and one child at most. Like there's one next paragraph and one previous paragraph.
Uh, yeah.
And then when you do a tree, each node can have multiple children, but it still only has one parent. And then you could also do a graph or a diagram, more generic words, where a node could have multiple parents in addition to multiple children. So you could just have like a spider web of connections going in all directions.
Yeah.
So trees don't give you all the freedom and possibilities, but for a lot of purposes, they're good enough. And you can sometimes add like a small amount of extra stuff, like some extra arrows or something if it's useful. And you usually probably won't need much more. But it is possible to have a more complicated type of graph with multiple parents for nodes. So trees are in the middle where they're more complicated than regular writing, but they're limited for how much they do. And they're usually pretty practically useful. Okay, so for making trees, I thought that math would be a good place to start.
Okay.
Um, so like suppose we do 2 plus 3. Do you know how to make a tree out of that?
No. Trying to think.
Yeah, also I was thinking it'd be good if you could share your screen somehow. I don't know the easiest way to do that. You could use Discord if you want. and then you could try to make a tree.
I don't have the tree software.
You can download Xmind, assuming you're on PC, and use the free
Okay.
trial.
Okay. Okay, so now I'm gonna think about 2 plus 3 tree. Okay, for a linear one, you could have it like 2, then plus, then 3, then equals, then 5. That would be a bit weird. But I think it would work.
Yeah, that would be a way of writing it linearly, very much like prose, like this. Where you just go in order, a 2, and then a plus, and then a 3, and then an equals, and then a 5. However, there's a way you can make a tree that is different than that. And also, don't worry about fitting the equals 5 in.
You could maybe do it like 2 plus 3 are 3 individual nodes that are horizontally aligned. Then they lead into the last node, which is 5.
That's like the same thing, except instead of a vertical line, it's a horizontal line.
The 5 would be at the bottom. It would kind of be an inverted pyramid, I think.
Oh, I see. Does the 5 have multiple parents?
Yes.
Okay, so if you want to do that in tree form, normally you put the 5 on top with the 2 plus and 3 leading into it. So that they're children, because that way you don't have multiple parents. Like you orient the tree so there's multiple children nodes instead of multiple parent nodes.
Mm-hmm.
So just flip it upside down and it solves that problem. You only need like the graph or whatever if you have multiple parents and multiple children. If it's only one or the other, then you could either you're okay or you can flip it and you'll be okay.
Okay,
But
so you only
try getting the tree software.
Okay.
What's up, everybody? What's up? Today we are doing 3 caps again. Yesterday I got the world record. You can see world record is now 124.55. But that run I lost 3 to 4 minutes on. There's a lot of big time saves in this run still. But yeah, I'm excited for today. I think we're gonna play. Just start the run off right now. Yep, copy date. Maybe I might have. I don't know. Good. Alright, let's start. Boom! First run of the day. I sound speed. I'm just energetic. I'm ready to go. I'm ready to game. Did someone squish small monkey? Did you modify it to squish small monkey? Monster. You squished him. No. Squish small monkey so hurts. Let's get the chat back on the rails a little bit. What can we talk about that's a little bit more productive? I'm trying to think of something that's worth talking about. Oh, he's rather than you. Oh my god. You know how Nintendo, they came out with Ring Fit Adventure? You know, they came out with Animal Crossing. All these games are really good for, you know, exercise and escape, you know, like some escapism. You know, what if they were unsure how well these games would sell? And, you know, they started this whole, like, worldwide pandemic thing to, you know, have Animal Crossing be one of the best games ever made, you know? Or one of the best-selling Switch games of all time. Probably have resources for that. Thanks for the conspiracy theory, no problem. It was all the video game companies, you know. What do we do? At the start of the year, no one is buying video games. And we're releasing all of these, like, banger games. But no one will buy them or try them out because they just don't have the time. They don't have the money. That's reset. Yeah, that's reset. You know, here's the thing, you know. We talked about it before, you know. We talked about how, you know, people ask me all the time, you know, how you get a girlfriend. And I'm like, you know, you be yourself. You improve yourself for the sake of yourself, you know. You improve yourself so you're better as a person. You know, some things that, you know, you get passionate about the things that make you you. And then also you get the 3 caps world record. You know, I feel like I'm pretty good on both of those things now, so, you know, I'm excited for the future is all I can say. I'm basically the perfect man at this point. And saying that, you know, is probably a negative thing, but I mean, I'm doing all the advice that I suggest you guys do, so, like, I mean, what else is there to do but, you know, just wait, I suppose. Or you can just get the 3 caps world record. So, you know, I'm trying mostly the 3 caps world record method, and I'll update you guys on how that goes, and, you know, I don't know how long it takes, but we'll see how effective that method is. I mean, I think, like, CJ can vouch for this. I think CJ has a girlfriend, and CJ did have the 3 caps world record, so I'm not saying that, you know, 3 caps did it, but definitely didn't hurt, right, CJ? You know, correlation, apply causation, no, it's causation, trust me. Watching this girlfriend now, yeah, I'm so sorry, CJ. I'm so sorry. Wait, no, I guess Ophir was with it. We need to hear about, like, Ophir's life. Like, Ophir had the world record for, like, what, a month? I'm sure all of his wildest relationship dreams have come true. Yeah? It's gotta be the case. It's gotta be the case. You know, Cameron, you know? No, you know. If you know, you know. Doug is live. He is speedrunning. Thank you for telling me that another streamer is streaming. No. There's no way. That doesn't sound right. No, I gotta check. No, wait a minute. Would you look at that? He is. That's incredible. A streamer streaming. Guess I'll good luck on the run. There we go. Okay. Yeah, that's amazing. Streamer stream. Who would guess? Who would have guessed? This is a kid's game? What are you talking about? Super Mario Odyssey is a game for full-grown adults that are trying to play a serious game of movement. You know, it's a story of deep love that Mario and Peach have for each other, going up against an evil antagonist that the likes of which the world has never seen before. This type of deep and complex story is not something that a child would be able to clearly comprehend and fully appreciate. It's deeper than that, all right? This is not a kid's game like Mario Kart, where we get on the little go-karts and race around in space, all right? It's deeper than that. Is the globe a capture? No, it's not the capture list. Here, I'll show you. So in this list, this is the capture list. You know, there's 52 things on this list. There's 52 unique captures in the game. You can see the wire is one of them. The things that aren't captures, you know, Scarecrow's, Bowser's hat is not on this list. Mario isn't in this hat. The globe isn't on this list. Checkpoints aren't a capture because a capture is considered something that you hit with Cappy to transform into and control. Levers aren't a capture. You never transform into it, right? The scooter, you're driving it, you're controlling it, but not transforming into it. How does the wire you enter with Bowser not count? If you hit that wire with Cappy, it doesn't capture it. It's actually only possible to jump into it as Bowser and not with Cappy, and so you never actually capture it. It's just a cutscene trigger. Like if you try to hit the wire with Cappy, which you can do in two-player mode, it does nothing. It doesn't actually let you hit it. Here's the thing. If anyone is like frustrated about a lot of people asking new questions and being like, you know, unaware of certain things in the stream, you know what that means? Either they haven't been here in a while or they just are new. Like those questions are understandable if, you know, someone's new in the stream and just doesn't know. I'm not upset about those questions. I do get a little bit sassy about it, but that's just my brand. Excuse me. That one was a bit of a stretch, though. Ooh, someone else is doing speedruns. Ooh, what? Someone else is doing speedruns. Let's see. Oh my goodness. Me, Linkus Fur, Nicrovia, Incredible Paco, Simi Chan, Philly Fan, Jin, Speedrun, Minato, Speed Gaming, Visual, Scurry, Clay. Wow, I would never guess that people are doing speedruns. Huh? That's so strange. I guess people are doing speedruns. Who would guess? It's like that's a thing that people do. Impossible. I thought only one person could speedrun at a time. You're more popular, so you're first. That's how the internet works, honestly. You know, the most popular person doing something did it first. All right. Feelings on Beta Whooper, I don't like him. He looks a little bit too much like Danny DeVito, which, you know, I'd rather not be sexually attracted to Pokemon. But you know how I say, like, you know, someone asks, how straight are you? On a scale of 1 to 10. You know, 1 being not at all, 10 being like perfectly straight. You know how I say like somewhere between 9.6 and 9.
Wait, Twitch finally added a speedrun tag, so you can just look at all the current speedruns going on. It's amazing. I wanted this for a long time.
Wouldn't there be something? It would make sense for custom tags where people could just add whatever they wanted, and then you could search that. Does that exist?
No, Twitch seems to have a list of like 100 tags. You can use those.
Mm-hmm.
Anyway, any trouble with the software? Are you got it soon?
Okay, I opened it. It's showing its trial mode, trying to figure out how it works now. It has a tutorial thing I'm looking at.
Screen share?
Okay, let me try.
9.8. I can still appreciate the attractiveness of certain men. You know how I've never actually said what men I can appreciate the attractiveness of? Have you ever considered I made them talking about Danny DeVito? All of the other people, they work so hard, and I just really, I can't move forwards. Do you see Mario just kept sliding backwards? Wait, did you see Cappy teleport? What? Wait, you guys saw that, right? Did Cappy like CRC or something? Why did it roll? No! Shit. Run's dead. Press the run button. We'll continue the run. Okay, we can still get 4 captures world record. What's your record in 4 caps, CJ? 128? Yeah, we can still get 4 caps record, which is hilarious. 1. And 2. There we go. And there we go. Sick. Alright, now we get the nut jump where you can see I lost 2 minutes and 10 seconds. So here we go. We're gonna submit this for 4 caps. The leaderboards have been rearranged recently where I wouldn't be able to submit this for 4 caps because it's not done on 1.3, which is required. Woo. Oh baby. Oh baby. We're up. The nut jump was successful. And now you do. Oh, XD. Woohoo. Let's go. Easy. How to lose 10 seconds in one easy step. Never practice killers. Alright, well, that is, I mean, besides that one mistake, that would have been a 3 cap world record, but for now, it is technically a 4 caps record, which is just hilarious. 123.39, let's go, 4 cap world record. I'm so sorry, CJ. Alright, let's start a run. Here we go. Round 2, let's go. So all I need to do is that run again. I just need to press Y this time, so that's what we're gonna do. Oh, you got it. Cool. Just hit the splits to save time. Yo, it works. Let's go. Okay, we're 7 minutes ahead right now. That's insanity. Yo, we're 12 minutes ahead. Best possible time, 108. Somebody slow me down. You seen this?
Okay, yeah, I can see what you're doing.
Okay, I was testing out the tab button. It opens
There's
a new
probably
thing.
also enter for siblings.
Okay, cool, you just had a challenge. Enter. Oh. Okay, yeah.
24 minutes ahead. The speed of this run is unparalleled, unmatched.
Jump down.
First try. More times. What? Is this the run? Is this it? It could be. I really. Okay, we must take time on that.
Okay, and then you could have.
No. What's happening? No. I was so far ahead. Come on. Where did I lose time? Only 33 seconds ahead right now. Is this a meme? No. No memes in the chat. Not at all. Go.
Okay.
Good. No, good. All right. First try. Excellent. Good pace. That's the hardest one. 1, 2, 3.
I think I know how to use it.
Okay.
Can I press delete? Okay, and that can be.
Should I show you 2 plus 3, or do you want to try more?
2 plus 3. I think you should show. I don't quite understand how to do 2 plus 3.
Okay, so two plus three has an inherent organization to it. It's not just stuff in a line. There's a way that the things fit together.
Mhm. Okay.
So fundamentally, the thing you're doing here is a plus operation.
Okay,
that's
plus
like the thing in
operation.
charge, the leader. You're doing addition.
Hmm.
Like that's the topic, the category.
Okay.
And then as inputs to addition, you have 2 and you have 3. These are the data points. They're like secondary things. They're the things the addition needs as resources in order to operate.
Hmm.
So you will see the point of this if you do a more complicated formula, such as like try this one. See if you can figure out how to put it in a tree structure.
Okay. So 2 plus 3 plus 4. Okay. Okay, so what we're doing that is also addition. Okay, so first 2 plus 3. So the thing we're doing. Okay, so the way I was talking, but I was muted. Oops. Okay, so the way that it normally works, I think, is like. Okay, so it's addition, and then you have the inputs, which is 2 and 3, and then the output would be 5.
Yeah, don't worry too much about the output. You could draw it on, but
Okay, and then the other thing we were doing was okay. What was the other thing we were doing?
here, it's back on screen.
Okay, so 2. Okay, so that's the thing we're doing. Okay, so this is 2 additions, so we could have 2 separate addition, or no?
Yes, having 2 different plus nodes would be good.
Okay. Okay, so first we do 3 plus 4, I think, and then we get that result and add it with 2. So,
That is mathematically correct.
okay, so it'd be more like 3 and 4, and then the output of that would be 7.
Don't worry about output.
Hmm. Okay.
Like, okay, this tree I have here, plus 2, 3. The
Okay.
value of this
Yeah.
tree, if you evaluate the entire thing, is 5. Like, this tree equals 5. So, you don't need to, like, separately say that it's 5. Like, you can, because then someone wouldn't have to add it. But the meaning here, this thing is, like, equivalent to 5. You could put it somewhere that a 5 would go, and it wouldn't change the result. Like, you'd get the same answer in the other thing.
Okay. So, like, the tree is 5. It is what
Yeah,
the
it's
additions
equivalent to
are.
5. It's worth 5.
Okay. So this is just like, so this would be a 7. So you could have it so that tab. Okay, and then you could do. Okay, so this is, if this was like 5, then you could do it. It's kind of like +2 or. Okay, I still don't think I'm really understanding it. I'm gonna try to write something.
Okay. So, alright, go ahead.
Hmm. Okay. I don't think I know how to do it properly. The way I originally was thinking of doing it is kind of like, okay, so you have like.
Okay, there's kind of a trick to it,
This
because you're doing it in the order that you would do it, like, for real, but the tree software is designed to do it in the opposite order of what you're trying to do. So you started with the 3 and the 4, and if you're using paper, it wouldn't matter. But, so the overall structure of this thing is we're adding 2 things together. The first thing is a 2, and the second thing is this group, 3 plus 4, right?
Okay, first thing adding is a 2, then 3 plus 4.
We're adding 2 with the group 3 plus 4. Does that make sense?
Okay, so like this is the group 3 plus 4, and then you want to add 2 into it.
Yeah. So, here, I'll just show you this.
Okay.
Does this make sense to you?
Yes.
So we add the 3 and the, I need to open a drawing app. So this subtree adds 3 and 4 together. That was a loud train.
Yeah.
Okay, so this subtree adds 3 and 4 together. And then the overall thing is we're adding 2 to that subtree.
Okay, so it's okay, so the subtree is 7, and then we can add like the subtree to the root, and then the root is also adding 2. That was a bit confusing. I think I said it.
Yeah. So we have a plus that's adding together 2 and whatever the result of 3 plus 4 is.
Okay.
So you were thinking about the 3 plus 4 first because when you're adding it, that's what you add first. So when you're doing the math, you add the things that are lower down in the tree first. But when you're making it in tree software, they don't let you start at the bottom and work your way up. You have to start at the top and work your way down. When that's a problem, you could use a different app, like a drawing app, if you wanted to. God, it's always dangerous to open things on stream. I don't know which screen it's going to pop up on and what document is already open in here. Shouldn't be too bad. Oh, I got a blank window. Okay. New. Okay, so what you can do here, got like a pen tool, is this one? I want a free form drawing tool. Is this? Oh, it's smoothing. I want like a basic fucking pencil. I haven't used this app all that much. Maybe there's a way you turn smoothing off or something. Oh, rope mode, window mode. Blend mode normal. Color none, sculpt. Rope mode. I'm just gonna look this up. Oh, can you just turn both stabilizers off? Do you not have to pick? No, it just makes me pick one. I just want one with no stabilizer or anything. Brush tool, maybe?
It shows like stabilizer check mark in the app. Is a stabilizer on at all to begin with?
I thought it was. Or maybe it's not. Alright, let me just get better colors. Where do I set color? Color. I need stroke. Width. That's not even red. I just set red. I don't understand this app very well.
Does it have like a secondary and primary color or something? And
Yeah,
maybe
I
you're
set the
changing
other
like
color. Okay, so here we could draw no, it totally just changed what I drew. Oh well, it's close enough. Alright, 3, 4 plus. Right, we can like hand draw this tree. And then we can start there, and then we can be like, well, we also have a 2. We need to add the things together. Right, so we can write out the bottom one first. If we're using pencil and paper.
but with software, you have to
Well, specifically with mind map software, they make you do it in order. There's different ways you can do it though. You can make the bottom thing and then like you can drag things around. You can let's go like stuff. Then you can make a linear list. So you have like a plus, a 2, a 3, a 4, and a plus. Right? And then you could like make a new tree and start dragging them in and be like, well, we're gonna need a plus and a 3 and a 4. And then what do? We need a new tree to add things together. So we're gonna make a new tree. And then we're gonna put like the plus and the 2. And then we can drag this over here. And we did it. Does that make sense?
I don't think I followed. Oh wait, you can do it like
Okay,
here's
so I
all
just
the
did
part
undo a
that's going
bunch.
to happen.
So here
Okay, so
I gathered all of the nodes we need, and then you can drag them around to construct your tree.
okay, so you can like figure out all the things, and then you can just like place out all the things, and then you can figure out how to attach them, kind of like pre-built Lego or whatever.
Yeah, so I drag the plus down and the 3 and the 4. Right?
Yeah, plus 10, and then 3 and the 4. Yeah, because that was one of the things we need. And then the other thing we needed was
To add that with the
adding.
2. So I just made another tree. and then put the plus and the 2, and then I dragged the first one over. Because you can't add a parent to it conveniently. Like, you only work downwards, but you can just drag it. So you could do it with this tree. You could you just add like plus and then drag it under, for example. So you have some options for working bottom up. Okay, so do you know how to add these things up? So when you add them, the way you evaluate is you start at the top at the root node.
Okay.
And you look at it and you say, okay, we're doing plus. We're adding things together. And you look at what are the things I'm adding, and those are the children. So we're adding 2 things. We're adding the 2, we're adding the plus. And the plus is not a number. So you have to say, okay, I'm not ready to add this yet, because I don't know what the second number is. So I'm going to have to figure out what this subtree is worth, and then I can add them together. So we're adding 2 plus something, and then to find out what the something is, we have to take this subtree right here and evaluate it. And then when it has a number, then we can do the original math. Then we take this plus and we look, what are the things we're adding up? What are the children? And we find 3 and 4. Then we add them. Then we get 7. And then we go back to the original plus and we see that it's adding up 2 and 7. Does that make sense?
Yeah. I don't think there's any way to like figure out what number it could potentially be at the beginning. You can't be like it would be at least 2 because what if it's adding a negative or something?
Yeah. Okay, so are you familiar with order of operations?
No. I recently learned about parentheses, meaning that you do that thing first. Useful for Google Docs.
Okay, so the default order of operations is left to right. Does that make sense?
Yeah.
Okay, so do you know how to put this in a tree without the parentheses?
Okay, put it in a tree without parentheses. Wait, were we even using the parentheses in the tree? I don't know.
They were, in fact, used, yes. That is why the 3 and the 4 were being added together as a group.
3 and the 4. Okay, so we kind of start from top down, so... Okay, so I'm gonna... Okay, so how did we do it to begin with? So it starts with like 2. Okay, what am I doing? I want to add things. What I wanted to add, 2 plus 3 plus 4 plus 4 into a tree thing. Yeah.
Okay, so if you're just doing the math normally, do you know which ones you add up first?
I do 2 plus 3, 5, then you can do 5 plus
and just
4.
assume that we're only adding up 2 numbers at a time, because you can also add like 3 or 4 numbers at once, but we'll just ignore that.
Okay, sweet.
So yes, you
Okay,
want to add
so
up the
it's
2 and
gonna
the
be
3 first, because you start on the left and go to the right. Whereas before, we started with the 3 and the 4 because they were grouped together with parentheses to give them priority.
Okay, so okay, so I think it's like 2, 3,
Yeah,
and then
so now you have this part.
okay, and then where does the next thing go? Okay, so we're adding. Okay, so these make up 5, and then we were adding 4 to 5. So
Yep.
how do I do this? Okay, so I think I need a new plus node. Okay.
Okay, hold on. Oh, I see what you're trying to do. Just drag them
Yeah,
one at a time, maybe that'll work.
oh, okay, I need to put them behind. Okay, so we get 5, and then we do 5 plus 4. So, okay, and 4. Okay, so what we're doing here is we are, okay, so we start from here. Like, what are we adding? We're adding 4 and something. We need to figure out this something else. And then we find out, okay, 3 plus 2, that means 5. So this is a 5. So then what we're doing here is adding 5 plus 4. So this gets 9.
Yep. So notice how it is a little bit different than the previous tree where the 3 and the 4 got added together first.
Yeah.
Because we don't have the parentheses anymore.
Huh.
So we're starting left to right. Okay, so order of operations. There are a couple basic rules. So it's just an order you look at things. So 1 plus 2 exponent 3 addition and division 4 addition. Okay, and we're not going to be worrying about exponents, but they're like a kind of normal thing. Be on the list.
Okay.
So that makes sense. This is like which things get done first and which things get done last.
Which things get done first?
So in this one, the pluses are they're a tie. They're both number 4, and because they're the same thing, they're always going to be a tie. So then we use left to right to break the tie.
Okay, left, right. Okay. I don't understand what the purpose of order of operations is. I don't know if that matters.
Okay, yes, it matters a lot. So I gotta make a good example. Okay. So if you look at this one, what does this make?
Okay, 2 minus 1, 1, then plus 3, 4.
Okay, but what if you did it in a different order? What would you get?
If it didn't. Wait, can I read? Okay.
So there were 2 different math operations, right? There's a subtraction and an addition.
Yeah.
Okay, so you did the subtraction and then you did the addition, right?
Yes. I don't know if I was supposed to get 1 or -1 from the subtraction, though. I think I forget how minuses work.
Okay. It's left to right. You start with the bigger number, or you start with the left number, which in this case is bigger.
Okay.
And then we're taking away 1 from 2, so there's 1 left over.
Okay, so we're taking away 1 from 2. Okay, then it would be 1.
So does this make sense? So subtraction is the same as adding a negative.
Okay, subtraction is the same.
Like it's 2 plus -1 is the same thing.
I think that makes sense, yeah.
Okay. And then it's the one on the right that comes after the minus sign that is negative.
Right. So
you're not going to make the 2 be the negative.
okay, if we wanted the 2.
Because there's no minus sign in front of the 2.
The minus sign in front of the 2. If it's in front of the 2, then if we had like -2 plus 1, then it would get down to -1.
Yep, you would start at -2, and then we go up 1 to -1. Are you familiar with the number line?
No, I don't know what that is. I don't know what that means.
Okay. Hopefully this will be not blurry. Hey, that's not bad. Okay, this is a number line. It just has all the numbers in a line, right?
Okay, then I think I might be, or I've seen it before. I don't think I'm familiar with it.
Okay, so to do 2 minus 1, you start at 2 right here.
Yeah.
And then you go 1 to the left.
Yeah.
And you end up at 1. As opposed to like if you were doing plus, like suppose we are doing 2 plus 3. Then we start at 2. And then if we're adding 3, we're counting 3 numbers. 1, 2, 3 to the right, because this is the positive direction. And we end up at 5.
Okay, starting at the bigger number seems easier because then you have to move less.
That's true, and with addition, you can swap the order and you still get the same result.
I think that also works with multiplication. I don't think that would work if you're doing division though, or like multiplication and addition.
Yeah. So with subtraction, you have to be careful. You can take 2 minus 1 and you can swap the order. But if you swap the order, you can't do 1 minus 2. That would be wrong. What you have to do is swap the order. You're doing minus 1 plus 2. Because the things we're adding together are essentially 2 and negative 1. So if you convert it into an addition, then you can swap the order.
An addition. Okay, so 2. So we have 2, and then we take away 1. So like 2 minus 1. Okay. And then 1 minus 2.
If we just flip it, we're going to get a different answer. Negative 1 instead of 1.
Yeah. 1. Okay, so we start with 1, and then we'd like take away 2, and that would be minus 1. But if we think about it like that, then
But we can flip it if we change it to addition, because equals 2 plus negative 1, which equals negative 1 plus 2, because additions you can do in any order.
Negative 1. Okay.
So I can show you that on the number line.
Goes to 1.
So one of them is we're starting at 2, and we're going left 1 point.
Okay.
The other one is we start at 1, negative 1, and we go right 2 points. And both of them end up with the same answer.
Okay.
Does that make any sense?
I think so. I still feel like I don't completely understand. Normally what I like to do with things like this is just look at it a while and like try to do things like, what if I had 3 minus 1? Oh, that would just be 2.
Yeah, we probably should have started with just positive numbers and addition for the number line. We got more used to it. Like, if we're going to do 3 plus 4. Do you know how to do that?
Okay, we start at 3, then we
Okay,
go
start
to
at
the
3.
right 4 times. So
1, 2, 3, 4.
2, 3, 4, 7.
Like that?
Yeah.
Yep, and that's correct. And what if we have like 1 plus 3? or 3 plus 1?
3 plus 1. We start at 3, then we go to the right once.
Okay, and then what if it is 1 plus 3?
1 plus 3. We start at 1 and go to the right 3 times.
And we end up in the same place?
Get 3 plus 1. 1 plus 3. I think those would end up in the exact same spot.
Okay, let me show you why they end up in the same spot. Oh, there's a trick to it.
Okay.
Okay, so let me write it out as text first. So 1 plus 3, 3 plus 1. There's a different way to look at it. It is 0 plus 1 plus 3. And it is 0 plus 3 plus 1. So these are the same because you're adding an extra 0, right? And
Yeah,
that's
the
not going to change the
0
number?
doesn't affect anything. If you
Yeah.
did something with division, or like multiplication, then order of operations might mess something up.
Yeah, you have to be careful of zeros with multiplication and addition because like 3 times 0 is 0.
Remember someone talking about on Reddit a lot of people being wrong about a math question because it ended or started with multiplication by 0 or something, and then people didn't do the order of operations or whatever, so they got the wrong answer a lot.
I see. So 0 is called the additive identity because it doesn't affect things when you're doing addition and subtraction. But for multiplication and division, the thing called the multiplicative identity is 1. So you can take a 3 and you can do times 1 times 1 times 1 times 1, and it doesn't change it. The same way you can take a 3 and you can do plus 0 plus 0 plus 0. So for multiplication, it's 1 that you can keep doing, whereas for addition, it's 0. You can do minus 0 as well, and it doesn't matter.
Okay.
And similarly, you can do divide by 1 a bunch of times, and it doesn't change it.
Yeah.
So 0 is the key number for addition and subtraction, but 1 is for multiplication and division. Anyways, so 0 plus 1 plus 3. How do we do that on the number line? What do you want me to draw?
Okay, 0 plus 1 plus 3. How do we do that on the number line?
Yep.
Okay, so we start at 0, then
Okay.
we go to the right one, and then plus
Okay.
3, we go to the right 3 times.
Okay, and we got it to 4. And then what about 0 plus 3 plus 1?
Okay, 0 plus 3 plus 1. Okay, we start at 0, then we go to the right 3 times, then we go to the right once.
Okay, and we got the same answer again. So
Mhm.
the trick to addition with the number line is all additions start at 0. When you do 1 plus 3, you're starting at 1 because that's where you got from 0. You go, the 1 means go from 0 to 1, and then also go 3 more. So start at 0, go to the right 1, and go to the right 3. Start at 0, go to the right 3, and go to the right 1. So the reason it doesn't matter is it's like start at your home, that's 0, and then walk 2 miles to the north, and then walk 4 miles to the north. That's going to be the same as if you walked 4 miles and then 2 miles, all in the same direction.
Yeah.
Okay, and so then when we have 2 minus 1, what that's telling us is start at 0, then go 2 to the right,
Okay.
and 1 to the left.
Yeah.
As subtraction is going left. However, you can also go 1 to the left, and then 2 to the right, and it turns out the same. Like if you walk north 2 miles and south 1 mile from home, or if you walk south 1 mile and then north 2 miles, you end up in the same place.
Yeah.
So additions are just how many miles you should go to the right, and subtractions are how many miles you should go to the left. And if all you're doing is walking left and right, the order doesn't matter for where you end up. And you always start at 0.
Yeah. Is it possible to not start at 0? What would that look like? Like, or could you even imagine it if you like started at 5 or something?
I mean, you can imagine it. You can start there. People start there all the time as a shortcut. They're like 5 plus 2, and they just go like this.
Huh.
But what 5 means is go up 5 from 0, and then go 2 more.
Hmm.
You can always add in the 0 part if you want to for extra clarity. Because these are mathematically equivalent. You can always put in the explicit let's start at 0 in front of additions and subtractions.
Hmm.
Anyway, that's getting a bit off topic, but what we're trying to do was, why does order of operations matter?
Yeah.
We had this one here, 2 minus 1 plus 3. And you did 2 minus 1 is 1, and then you added 3 and you got 4.
Yeah. So
And I asked, what if you did it in the other order?
if you did it in the other order, so minus or minus 1 at the
So go from right to left instead of left to right.
right to left. Okay, so 3 plus 1, 4, then minus 2, 2.
Okay, that was kind of confusing, but what I meant was do the mathematical things from right to left. So first you do the plus, you got 4.
Okay.
And then we're doing 2 minus 4. We're still reading the subtraction from left to right, otherwise it totally changes. Does that make sense? Like we're going to do the addition and then the subtraction. But it's still going to be 2 minus 4, not 4 minus 2.
Okay, it's going to be 2 minus 4, not 4 minus 2. Wait.
Okay, just think of it like, imagine that the order of operations was you do all your additions first, and then you do all your subtractions. Does that make sense?
Okay. All your additions first, then all your subtractions. Okay, so if we did the additions first, then it would be 1 plus 2. I mean 1 plus 3.
Yeah.
And then that would mean we
So
get
this
4.
would equal 2 minus 4, which would equal
2 minus. Okay, so it'd be 2 minus 4, which would be alright, so it's 2 take away 4, so that'd be negative 2.
yeah, 2 to the right and 4 to the left. Ends
Okay.
up 2 to the left.
Right, 4 to the left. Yes.
To the right, and then we turn around and we go over this way and we end up here.
Mm-hmm.
Okay, so originally when you did it, you got 2 minus 1 is 1, plus 3 is 4. The answer was 4.
Mm-hmm.
You started at 2. You went 1 to the left. And then you went 3 to the right. And you ended up here.
Yeah.
But with the new order of operations, it was... you got to 4, but then you subtracted that. It doesn't even work well on the number line to do it the other way. But anyways, the answer changed from 4 to negative 2. It was a big change, right? Totally different answer.
Yeah. Yeah.
So the reason is, in the original, the 2 is going to the right, and the 3 is going to the right. So we have like 5 positive points, and we have 1 negative point.
Mm-hmm.
But in the changed version, where you do this first, then the 3 ended up being negative, because you were subtracting 1 plus 3. So the proper way to write that is with parentheses. This. If you do 2 minus group 1 plus 3, now not only is the 1 negative, but essentially the 3 is also negative, because it's part of a subtraction group. And that's why you end up in a different answer. Instead of the 3 making you go to the right, the 3 ended up making you go to the left. In this
Okay,
one, we're going 2 to the right, 1 to the left, and 3 to the left.
This one we're going. Okay, so the first thing we do is add 1 and 3 together, and that gets us 4. And then 2 minus 4 minus 2. That would mean minus 2.
Yep. You saw how the 3 ended up taking us to the left there? Like you went over to the 2, and you went 4 to the left. So the 1 and the 3 were both going left.
Yeah, the 1 and 3 were both going left. Before it was only the 1 that was going left, because it was 2 minus 1. And that gets us to 1. And then we get a plus 3, which takes us to the right.
Yeah, so that is why order of operations matters, and it comes up even more if you have addition and multiplication. So suppose we have 1 plus 2 times 3. This is markdown, so I have to put like a slash in front of the times, or it thinks that I'm making italics. Anyway, so if you do 1 plus 2 times 3, do you know what that makes?
Wait, so it's 3 times 3, so 9, I think?
Did you follow order of operations?
No.
So you just did left to right, right?
Yes. Okay,
Right.
so first we do the multiplication. So what are we multiplying? Okay, so it's written out as 1 plus 2 times 3. So we need to do the times 3 first. I don't know what we're multiplying. I think we're multiplying 1 plus 2. I don't know
We're
how
just
to...
multiplying the numbers next to the multiplication. Same way in the previous ones, whatever operation you're doing, you just take the 2 things next to it, the one thing on the left and the one thing on the right. Does that make sense?
Okay.
Like, you can multiply the 2 with the 3, and then you could worry about the addition part later.
Okay, we can multiply the 2 with 3, then worry about the addition part later. Okay, I think that makes sense. So, okay, so we're multiplying 2 times 3, so we get 6. Then multiplication done. Then it's 1 plus 6, so we get 7.
Yeah. So, order of operations means that these 2 things are equal. Here I put in the parentheses, because the parentheses show you more directly, do this part first. Does that make sense?
I think so. I don't quite understand the numbers next to each other doing those. Oh wait.
Like,
So you
if
have
I write
like
2 times 3, the 3,
okay.
or sorry, the times says multiply the 2 numbers next to me, the one on the left and the one on the right.
Okay, so that's what the time says.
Right, and then if I wrote a 4 here, you'd be like, what do I do with the 4? Because it doesn't have any any operator. But if I write like a plus, now it makes sense again. You do these, and then you have this is on the left and the 4 is on the right of the plus. The plus is the thing that guides what you do.
And also, if we
Just
just had a plus without anything else, that wouldn't. Or like if we had the 2 times 3 and then plus, that wouldn't make any sense if it didn't have anything else next to it.
Yeah. So the order of operation stuff is easier to see with trees. They make it clearer, and they mean that you don't need parentheses, and you don't need order of operations. All you need is the tree, and then you know what order to do everything.
Mhm.
Like, if you have the tree, you can figure out what order to do things. So I will just make a tree. Okay, so here's my tree.
Mhm.
Now, to figure out what this number is, you don't have to know, does multiplication come first or does addition come first? The tree tells you what order to do things. You don't need any parentheses, because the tree tells you what order to do things. So see if you can figure this one out.
Okay, so we could start at either branch, I think. Okay, what we start at is the root. Okay, so what are we doing? We're doing some kind of addition. Okay, so we want to add the 2 different branches. Okay,
Yes.
what's the left branch? It is a
Starting on the left
multiplication
is the
thing.
most common, but if you did the right branch first, you wouldn't be wrong. Like, you'd still get a correct answer. It doesn't really matter, but going left to right helps you stay organized.
So it's like helps you stay consistent. I remember thinking
Yeah, because
about
if you
this with
always
like,
do it that way.
yeah, I remember thinking about it with like an options thing, where I was like looking at an options menu, and I was like in like a text file, and it would be or it always ended with like true means it is enabled, so it would be like clouds enabled, and then it has like the true or false option. If you had like clouds disabled and like trees enabled, then like true and false would mean they're both. Uh,
Yeah, I get it. That's pretty common
yeah.
that they actually have options that go both ways, like checked enables it or checked disables it. It's
Yeah.
pretty common to see a mix, so you have to like read everything more carefully to figure out what's on and off.
Yeah, so having it like consistent, so like true always means it's enabled, seems good.
Yeah.
Okay, and what did that have relevance to? Starting from left to right, even though right to left works anyway?
Yeah.
Okay, so we're doing multiplication. So what are we multiplying? We're multiplying 5 and 2. Oh yes, I guess you can only have 2 numbers when we're doing an... What is it called? Are we doing an operation? Is multiplication like an operation?
Yes.
Like, what is it called?
It is a
Okay,
mathematical operation. Times is a operator or a function.
okay, so you can only really have like 2 things for like a normal operation. Like if you're doing addition, you need 2 things. You can't really have more or less, I don't think.
You actually can, but that's not normal. Normally people do it with exactly 2 things.
Okay, so it's possible, but it's very fucking abnormal.
Yeah, so when you write the normal way people write math, which is called infix, because it means that the plus is in the middle. So I'll show you. 2 plus 3 infix, because it's in the middle. And then there's plus 2, 3 prefix, because the plus is at the beginning and pre means beginning, whereas in means in the middle. And then there is 2, 3 plus, which is postfix, because post means after.
Mhm.
And when you use infix, it encourages you to have exactly 2 things, one before and one after, so that you can be in the middle. It doesn't work very well with
Yeah.
different numbers of things. However, with the other ones, it doesn't matter. You could write plus, if we're doing prefix, we could write plus 2, 3, 4, 5, and be like, add all of those, and it would work fine.
Wow. Huh. Didn't know about prefix and postfix ways of doing it.
Yeah, so there's programming languages that let you do this, where plus takes any number of arguments. So you can figure out what this one equals, right? You want to add it up?
Okay, the way I'd kind of do it is just turn it into infix, I think. So I'd just be like 2 plus 3, 5, then 4 plus 5, 9, then 5 plus 9, 14.
Yeah, that's fine. Doing it in steps makes sense. Okay, so then, what if I gave you plus 2? You know what that one would equal?
No, plus 2. I'm trying to think about it. At the moment, I don't know. I just have like kind of guesses, which I'm trying to figure out.
Okay, well, the number line is a big help here. So, I'll just do a simpler one.
Oh, so 0 plus 2.
Yes. So when we're doing plus 2, 3, 4, or whatever, or just plus 2, 3, we're going like this, and then we're going like this. So if we're only doing plus 2, what do we do?
If we're only doing plus 2, I think we start at 0. Or like it would be a 0 plus. Alright. I think I'm still confused.
Yeah, we start at 0 and we go 2 to the right. So this one was go to the right by 2 and 3 and 4 and 5. We're doing 4 different walks to the right.
Oh, thinking about the prefix, the first prefix thing like that, makes sense.
Yeah, and then in this one, plus 2, 3, we're doing 2 different walks to the right. In this one, we're just doing 1 walk to the right.
Mm-hmm.
So where do we end up?
2 miles.
2 miles to the right. Okay, and then prefix. What if we just have plus and there's nothing listed? Where do we end up?
0.
Yep. So you could add in the zeros if you think it's clearer. You could be like 0, 0, 0. Or you could be like plus 0, you know, or 0 plus 0. But it's the same either way. There's just no walks to the right, so we stay home. Home is 0.
Wait. So, with an infix, would it work to just have it say plus 3, and then that means 3?
People sometimes write that, but it's not really infix, it's a different thing. So you can write like -2 like this. Have you seen that before? You could, where people just write like, this is a way of writing a negative number?
Okay, what is this? A way of writing a negative number. -2. Yeah, I see that.
Okay.
Just
Anyway,
-2.
So sometimes people might write plus 3, and it's a way of writing a positive number, but they're just trying to say is it's like positive 3. But it's not common because the positive is the default.
So, like, if you're doing a bunch of things with, like, if for some reason you were doing a lot of negative numbers, then it might be good to have it as plus 3 to clarify when it's a positive number.
Yeah, maybe. So this is not addition, and this is not subtraction. It's just writing a number using more than one letter. Just like,
What if we...
just like 222 this is one number, even though there's 3 different digits involved. This is one number, even though there's 2 digits, a negative sign, and a 2.
Okay, if we add a space between the operator and the number, would that make it a prefix?
Like this?
Yeah.
This is just, this is like not normal. I mean, if you want to do prefix, you have to like tell people you're doing prefix or something.
Oh.
Anyway, so Infix, because they're always putting the operators in the middle, they use pairs of numbers. And they use order of operations.
Use pairs of numbers and orders of operations. So you don't use like 3 numbers for infix. Can you use 3
Yeah.
numbers for infix?
No, there's no way to write
Okay.
it. But with prefix and postfix, you don't need orders of operation. And you can add different numbers of things with 1 plus. Anyways, so we're trying to do this tree. So if you want me to, you could copy the tree into your app, or if you want, you could tell me and I will write like notations on it somewhere. Like if you want me to write something so you can keep track of your work as you go along.
So I can just tell you to do things, or I can.
Yeah, I can just write on my screen. Or you can take a screenshot of it and then you could write on that on your screen, I guess. Maybe that would be easier. That'd be a quick way for you to get a copy is with a screenshot.
I'm terrible at handwriting numbers.
Okay, well I can do it this time.
Okay, so what? Wait, I minimize that. Keep it open. Okay, so I'm just gonna start doing things. Yeah, what do I want to do? This tree. Okay, what's the tree? It's an addition. That's what the root is doing. We're adding 2 things.
Let me just change the tree real quick because what we just talked about. Because you were asking if it always had to be two children for everything.
Mm-hmm.
So I'm just gonna put an extra 2 here. And have a third children under the plus.
Cool.
The tree is really easy and doesn't matter. Okay, now go ahead.
That's sick. I never knew about postfix and prefix things before, and it seems really interesting.
Yeah, in general, prefix is actually the best one. People just don't use it very much.
Do people use postfix?
No, that's not popular either.
Okay.
Prefix is the best one because it puts the operation first, and the operation is the important thing, like plus is more important than the numbers. Which is why, in the trees, I have plus at the top instead of a number at the top. So if we're doing a postfix style tree, we would have all the numbers towards the top and the operators towards the bottom. Whereas in this one, you see how every number is a leaf node?
Every number is a leaf. Yeah, every number is a leaf.
No number has something under it.
Yeah.
And every operator is a non-leaf node. It has, it's not the end of the tree.
Mm-hmm. Okay, so an operator can operate on the numbers, right?
Yes.
So having an operator that doesn't operate on anything doesn't make sense, I think. So it kind of has to be a node with a child.
So postfix would look a little like this, where you would have the numbers at the beginning, and the operators at the end as the lead. And postfix is a lot harder to write with mine node. It's more convenient to write the other way.
Okay. Okay, so the tree is an addition tree. Then there's the multiplication. And that's 5 times 2. So that's just going to be 10.
Okay, and then there's a 10 somewhere?
Sure, maybe like next to the multiplication symbol.
Okay.
Okay, and then we're dividing, I think. So, what are we dividing? something and 2. So it's going to be something divided by 2, which can also be thought of like how many times can we put 2 into something?
Yep.
Okay, and the something is an addition. So what are we adding? We're adding 1, 5, 2. Okay, I'm just going to do the 5, or I was going to just try to do the 5, 2, because that seemed easier to do. But I'm going to just try left and right. Okay, so 1, 5, 6. Then 6, 2, 8. Okay, so we're dividing. Okay, so
Like this? Are these numbers what you wanted? I'll correct them when you're saying them.
yeah, seems good. Okay, and then we're dividing 8 by 2. So how many times can we put 2 into 8? That would be 4. Is there a different way to divide things? Probably. I think I forgot it, but that I've done it a lot before.
So I'll let you finish this and then I'll tell you about division.
Okay.
You got the
So
right answer
then,
anyways.
wait, so then what are we doing? Oh, we're
Right,
14.
what's left?
Sick.
14 you said?
Yeah, because we're like adding the multiplication and the division. The division is a 4, and the multiplication is a 10. So that means 14.
Yes. So I will now write this out in regular infix notation with parentheses. We're doing plus, and then on the left we have time, or 5 times 2. We have plus. Then over here we have divide, or we have divide in the middle, and then 2 afterwards, and then before that we have 1 plus 5 plus. So this is that tree. Does that make sense? Try to look at this and see if you can match up how it fits with the tree.
Okay, trying to. It looks harder than the tree, but I'm trying to figure out what it is. Okay, I don't understand
I'm just going to use an X
multiple
instead of a times sign so I don't have
parentheses.
to write a slash.
Hmm. Okay. Okay, so when there's multiple parentheses, the tiebreaker is the left one first. It seems like everything is in a parenthesis.
Oh, for separate parentheses, yes. However, for internal parentheses, they go before external parentheses. Like, if you have a parentheses inside parentheses, the ones in the middle go first. The ones that are
Okay,
more nested.
so with that thing, we'd first do, okay, well, first we do the 5 times 2. Then we wouldn't do the addition because there's parentheses before that addition. So additions is like the last thing because everything else has a parentheses.
Yes.
Okay, and in the first parentheses, there's a second layer of parentheses. So we do the second layer of parentheses first.
Yeah.
Okay, so the second layer of parentheses, it is just addition. You could draw that with a prefix addition as well, I think.
Yeah.
Okay, so that's 1 plus 5 is 6. 8. Okay, 8 divided by 2. Do we do 8 divided by 2 then?
Look
I
over
guess
here.
we.
Right here.
Okay,
This.
yeah. Okay. It's 8 divided by 2. Or is it? Okay, we have the division, and then what are we dividing? The 8 and the 2. Yeah. Okay. 8. And then we divide that by 2, and we get the 4. and then we add, from left to right, we add 10 plus 4, and then we get 14.
Uh-huh.
Okay. The tree looks a lot less condensed and easier to like read and follow. I don't know
Yep.
how much of that is just like inherently benefit of the tree and how much of that could be like easily gotten, or if
I
you
think the tree is actually just easier.
so it's not just like if you spend like 100 hours with the tree doing things like this and 100 hours with like what is it called? Is that
Infix?
no? Okay, just the entire opera. What is it? I don't know. What's the line that I was just looking at?
This thing here?
Yes. What is that
That is,
called as a
it's
whole?
called arithmetic or infix arithmetic, if you want to specify.
Okay, so that was an infix arithmetic thing. I don't know if that entire arithmetic thing, like if you spend 100 hours doing things like that, where it's like a bit more complicated with like a lot of parentheses and stuff,
It
and
gets a
100
lot
hours.
easier, but I think the tree is still easier at the end.
Huh. Okay. That's basically what I wanted to ask, yeah.
Yeah, so no, the tree is not infix. It is prefix because like plus has, well, it's easier with a smaller tree. Like this one here. You can see it's prefix because we have the plus first is the parent, and then the numbers are the children. So that is like this one plus 2, 3. Where the plus comes first.
Yeah, so that makes sense as it being a prefix.
Yeah, so infix doesn't even work in trees because it's not as good of a system, basically. But you can make trees with postfix, but we're not going to worry about them.
Okay.
Okay, so the notable thing about the tree, part of it, is you don't have order of operations. You don't need to worry about it. Like you don't have to know that like plus comes before times or vice versa or something like that. Like in a tree, the tree tells you the order based on where things are. Like the plus is on
Yeah.
top, so you're actually doing it last. And then you do this plus, so that was the first thing you do, so you actually start with a plus. And you don't have to have parentheses to tell you what order to do things. You can just move things around in the tree to do them in a different order. Like, if we wanted... What would be a good thing to move? Like, if we wanted that thing to get divided and like this thing to be added up, we could just move them around and drag them around without using parentheses. And now I have another tree, and this is a valid tree. You can tell it's a valid tree because every leaf node is a number, and all the other nodes are operators. So every operator has numbers to operate on. And then none of the numbers have something under them that are supposed to do something.
Is it possible to have a number that is not a leaf and still be valid tree?
So if a number was not a leaf, you'd have to have something, a child of it. So what would the child be? Like, would it be a 2? Or maybe your child would be a plus? What does 2 do with plus? So if you have a plus down here, what's going to happen is you're going to have like 2 and 2, and then this node will be equivalent to 4, so it'll just like, it'll be like having a 4 under a 2. If you have a plus under a 2. So either you can have a number under the 2, or you can have an operator under the 2 that turns into a number anyways. So having a number under a number doesn't really make sense.
Right. So I don't really understand how this thing is doing. Okay, so there's a 2. What is the 2 doing? I don't know what the number is doing to the 2. I don't know if the number does anything to the 2.
Yeah, it doesn't make sense. Like, it's just incorrect.
So it's just like improper formatting. What the fuck are you doing with this number here?
Yeah, and if you put a plus under, I was trying to say, like, instead of putting a 2 under, we'll put a plus, because maybe, like, it'll help somehow. Then what do we do
Yeah.
with the plus? We find out that 2 plus 2 is worth 4. So
Okay,
now we
so
just have a
it's
4 under the 2.
yeah. Like what am I doing with the 4? This makes no
Yeah.
sense.
So it still doesn't work. So
Huh.
we
Okay,
should
so if you
not
can't
have
put a
numbers in the
number,
middle.
so if you can't have a number below it or an operator below it, then I guess there's nothing we can have below it.
Yep, numbers are always the leaves.
Hmm.
An operator could be a leaf, sort of. So what you could do is you have plus here. Because we went over this earlier, like prefix. What if you have a plus with no numbers? You end up at 0?
If you have a plus no numbers, it ends up as
You
0.
just don't want them.
Yeah.
So I
It
could add a
doesn't even
plus
tell you
here.
if it's gonna be in the positive direction. It's just a nothing kinda.
Yeah, walk 0 miles to the right, or don't do any walks to the right. Anyway, so I could add a plus to the tree and it wouldn't break it, because we could say this plus is worth 0.
Yeah.
But we can't add random numbers to the tree. And doing this isn't very useful. It's a little bit useful because you can say, like, I have this list of numbers that the user typed in, so add them all up. And then if the user didn't type in any numbers, you get 0 instead of an error.
Okay. Hit this list of numbers. Add them all up. So how would it become an error? Is it like if you're trying to do infix?
Right, so if you're trying to add up numbers and there aren't any of them, like a lot of people would say, oh, that's an error, like it can't add like that.
Mm-hmm.
But with this concept of addition, you could have the user could type in 0 numbers or 1 number or 2 or 3, and then the addition would know how to deal with it.
Mm-hmm.
But you normally wouldn't type in like a plus with no numbers yourself, because like why bother? Just write 0.
Plus. Okay, but it would make sense if it was like as a part of an automated system, where like
Yeah,
sometimes
and
it could have something, or maybe not. Who knows? Like something will happen sometimes, so might as well make it a prefix arithmetic so it can handle with anything.
okay,
Or
so
prefix addition. I don't think.
before we got 14. Now,
Yeah.
what if we remove all the parentheses? You want to try to figure out what this is? Using order of
Okay.
operations.
Okay, so first we start with parentheses. Those don't
Here,
exist.
why don't you get a
Exponents
text editor
don't
open?
exist.
Well, open up Atom or something, and I will message you this on Discord.
Okay, I haven't really used that in a while. I think I'll just use like a fucking text file or something.
Okay. I'm gonna BRB. You can keep going.
Okay. Okay, so order of operations. Which one's multiplication and division? So where is the first multiplication or division? Okay, this is a multiplication. Okay, so the first thing we do is 10. Okay, now I got 10. What else? Any other division or whatever? Okay, a division by 2. So 2 divided by 2. Oh boy. Okay.
Okay, hi.
1. Hi. So far, I did
I can hear you.
Okay. Okay, so 1. So we can kind of put it like this. So this just becomes like 10 now. And this is just 1.
Yep.
And now we only have addition. And we just do that from left to right. So we can get an 11. Okay, and then we get a 16. And then we get 17.
Yep. So did the answer change?
Last answer was 14 when we used parentheses, I'm pretty sure. So it changed.
Yep. The basic reason it got changed is in the other order, the 1 and the 5 also ended up being divided by 2.
To
More
1.
stuff got grouped together and then divided by 2.
Okay. So if you only have, say, multiplication, and like that's the only operator you have, and then you could just add as many numbers as you wanted, and I don't think it would matter what order you put the multiplication in, it would always just equal the same thing.
Yes.
Okay.
Okay, so look at the tree again. Here
Tree.
it is. The reason the order matters is you can see that under the division, what do we have under it? We have this, 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 and this. So like all 3 of these things got divided because they're all in the division subtree.
Yeah.
Whereas when you did it, you did 2 divided by 2, and you got 1, and the 1 and the 5 got left alone. But here, the 1 and the 5 are in the subtree of the division instead of separate. Does that make sense? They're nested or grouped under the division. They are grandchildren of it.
So somehow they're going to be divided in some way.
Yeah. Whereas
if they're under the tree.
Yeah, when you did it, the 1 and the 5 had nothing to do with the division. Like they were still just waiting when the division was done.
Yeah, I just divided 2 by 2. And then the 1 and the 5 were just like...
Yeah, so I will make a copy of this. And then when you did it with regular order of operations and no parentheses, what you did was like this. We're going to put the 1 over here. We're going to put the 5 over here. They both just were under the original plus.
Yeah.
And this is the tree you did. I guess we can delete this plus, but harmless. Alright, deleted the 2 with it. There we go. So this is what you did when it was no parentheses with regular order of operations.
Yeah.
Okay, and then do it one more time.
Okay.
Same thing to start with. And now ignore the order of operations and just go left to right.
Okay, so I'm just gonna move this out of the way. Okay, so just left to right. Okay, so we get a nice little 10. Okay, then we get an 11. How do you do this? Control. Oh. Okay, then we get 16. And then, okay, 16 plus 2 divided by 2. Okay, trying to figure out how this works.
Okay, well, there's two different operators, right? There's a plus and a divide.
Yeah.
Okay, which one are you doing first?
I guess the one that exists first. So, oh, okay. So I think the way it will work is I add these numbers together, and then I divide that by 2. Okay, that's probably how it's gonna go. Okay, so this is gonna be an 18
Yep, because the
divided
plus
by
is on
2.
the right, or on the left, I meant.
Okay, then divided by 2 gets us to 19. It might be better if I just like
Wait,
make a
hold
new
on.
line.
Go back. 18 divided by 2, what is that?
Did I say 19?
You did.
Okay. Okay. 18 divided by 2. Right now, I feel like that's a 9. I'm trying to figure it out though, because I could have forgot. Okay. 9 times 2 is 18. Therefore, divided by 2 would probably also be 9.
Yes. Alright, let me show you real quick how I would write it out. Or a way to write it out is you kept editing what you did, but you can keep adding new lines, and then you'll keep your whole history of what you did.
Yeah, that seems better.
And then if you make a mistake, you'll be able to go back and figure out what happened.
Yeah, instead of just like writing all of it over. Oh no, it's in a loop. Okay, so you can have it like this line, and then it becomes a 10, and then wait, what? Yeah, that's how you do it. Okay, then it becomes oh, well, you need to copy the new one. Okay, then it can become an 11. Then you cut that. Then you go down. Okay, then it becomes 16. Huh. Okay, so you want to do like that, then 18, and then you can copy that down, then you can do 9. Okay, so like that is better, I think.
Yep. So the answer changed again. So I'm going to make a tree of the last one we just did. Make a
Okay,
tree that shows
last one.
doing it in this other order.
Okay, so a tree that shows us doing it in this order. Okay. How do you tree that? That's what I need to figure out. Okay. Stream goes on this thing.
Like
Untitled stream.
previously, we had the original tree, and then we did the second order, and I made the tree that showed in that order. And then you do the third tree.
Wait, say that again?
We had the original tree here.
Mm-hmm.
And
Original
then
tree.
I made this tree, which was the second order we did them in.
Mm-hmm.
And then you make the third tree. This one's just a copy of the second tree. Didn't edit it yet.
Okay. Then I make the tree. So, what's this? Maybe I should make previous trees as well to see
If you want.
what is that. Okay. Okay, so how can you do this in a tree? Okay, so what is a tree? What are we doing to begin with? If we're just doing infix things, then we can only have 2 numbers for every operator, I think, if we're doing infix. If you want to like make an infix on a tree and pretend it's infix, then you can only have 2 numbers. Okay, so what is the final thing we did? It was division. So this one wants to be division, I think. And then what were we dividing it by? We were doing an 18 divided by 2. So it was like 18 and then 2. I'm going to need to change this because you can't have the numbers be the top things. Okay, so like how did we get to 18? How did we get to 2? And then we can like put the operators for that.
Yes, that is correct.
Okay, so 2 is just always here, so 2 can just stay there. So how the fuck did we get to 18?
Yeah, it might be easier if you did it in sort of the opposite direction, like building the bottom of the tree upwards, but what you're doing will also work.
Like, I'm just gonna keep doing it like this now. Okay, so from 18, we had a 16 plus 2. So 18 is now going... 18 turned into a plus. Okay, then what was it adding? It was adding a 16 and a 2. Okay, so how did we get a 16 and a 2?
The formula history here helps show you what to do.
Yeah. Okay, so there was 16. We got 16 plus 2. How did we get 16? 11 plus 5. So 16 is turning into a plus. Okay. Okay, 11 plus 5. How did we get 11? It was 10 plus 1. 10. 1. Okay, how did we get 10? It was 5 times 2. So this would be a times. Yeah, apostrophe. That's not an apostrophe. Star, sure. Okay, 5 times 2. Then 5, 2. Okay, so did we reach the bottom of that one? Yeah, 5 times 2 was the original thing there. Okay, so that made a 10, then it made an 11, then it made a 16, then it made an 18. Okay, so then where did these other numbers come from? Let's start with this
Well, look at the original formula and see what numbers are in it.
original formula and see what numbers in it. Okay, there's 5 times 2, and then... Okay, the only things in it were the 1 division and the multiplication. Multiplication, and then everything else was just addition. So I think all of these just being divisions. All of the remaining leaves just being like a part of multiplications, I think would be fine. What am I saying?
I'm not sure.
Okay.
Do you see my screen?
Oh. Your screen. So you have it, like, you show where the 5 is, you show where the 2 is, show where the 1 is.
Every number in the original formula ends up 1 time in your tree.
Okay, so that should mean everything is fine.
Yep, and also the operators. Also, I could draw lines for the operators. The divide to the divide, the plus to the plus, the plus to the plus, plus to the plus, and the times to the times.
Okay.
We have the exact same stuff. The same digits and the same operators.
Okay, so if everything shows up in the tree, then the tree... What does that mean? It
It
means
means you
everything
didn't
is accounted
accidentally
for?
add or delete shit.
Doesn't mean everything is done in the same order. No, we could have them all be the exact same line. They could all be siblings. That would be the wrong order, but everything would still be there. So it doesn't imply that everything's in the right order, but it does
Yeah.
mean
But you
everything.
checked it, I think. You went through and you were like 5 times 2 is 10, plus 1 is 11, plus 5 is 16, plus 2 is 18. And you have the 18 divided by 2.
Can I make okay, so this, and then I can have it show like 10.
Yep.
Okay, so that becomes 10, and then that becomes 11.
If you select one of those nodes, like the 10, and then you copy paste, you might be able to duplicate it. I guess not. Never mind. Also, in my node, you can just hit Shift Enter to make a new main node, but probably won't work.
Yeah.
There might be something in the menus you can, but you got it anyways.
Okay, good enough for now. Okay, so then it's 11 plus 5, which becomes a 16. And then 16 2 becomes the 18. And then divided by 2, 9. Yeah.
Okay, you see my screen?
Yeah. Okay. Shows the 5 is okay, then it shows how it comes into a 10. Then from the 10 it turns into an 11. And the 11 becomes 16 because we added the 5. And then the 16 becomes an 18. That becomes a 9. Okay.
So it helps you see how the tree and the regular written out math are equivalent. Like you can see the connections between how they're doing the same thing.
Yeah. That makes sense. You can see like the same thing in a different format.
Yes. A tree is a different format, but it's still the same math. The math doesn't actually change. There's just a different way to write it out.
Yeah.
Okay, the other thing, you asked what division is. Do you know what multiplication is?
Multiplication. I don't know.
Okay, multiplication is repeated addition. Does that make any sense?
Yeah. Pretty sure I've heard that before. Pretty sure that's been explained to me before. Okay. So repeated addition. How? Okay, so if you have 3 times 5, is that adding 5 3 times?
It doesn't actually
Or
matter
adding
because
3
it's the same
5
either
times?
way. Whatever you
Adding
do.
first number by second or second number by first?
Yeah, it comes out the same.
Yeah.
But I would take the first number and add it up the second number of times as a default.
First number.
Because it's more left to righty, I think.
Okay. Wait, so say that again?
I would just start on the left. So we're
Okay.
repeatedly adding something up. So I take the left number and say that's the one we're repeatedly adding up. Just as a default standard. So I wrote on my screen like 3x2 equal add up 3's and do it 2 times.
Yeah. Sometimes it can be nice to flip them around if one's easier to multiply. Like if you're doing, say, 10 times
Yes.
7, you could try to do, yeah.
Okay, so if we had if we had 1 times 3, how would we write that as repeated addition?
Okay, 1 times 3. We could do that as 3 1s. Wait, 3 1s, 1 3s. How does that become addition? Okay, 3 1. So 1 plus 1 plus 1.
Like that?
Or
Is that what you said?
yeah,
Yep.
or just 3 plus.
Yeah, we could
Or
also just have
would it be
0
called
plus
plus 3?
3, or just plus 3 or whatever. Okay, so that's multiplication. Then what is division? Division is repeated subtraction. So 4 divided by 2 equals, how many times can I subtract 2 from 4?
Oh.
For this one, the order matters. You can't just swap the 2 and the 4. It's the same as subtraction order matters, like 4 minus 2 not equal 2 minus 4.
Okay, 9 times this. 2. Yeah. Oh yeah, and so if you think of it as like repeated subtraction, then if you like divide something by 0, that's how you can get infinite, because you can infinitely take away 0 from like 10 or whatever.
Yep. So how many times can you subtract 0 infinitely many times? And you still don't get home. Yeah. Okay, so the different way to look at 4 divided by 2 is with the number line. You start at 4, and then how many 2-mile walks do you have to do in order to get home? So division of 4 divided by 2 means 4 is our starting point, and we're doing walks in 2-mile chunks. We walk 2 miles at a time. So it's how many walks do we do?
Yeah.
1 walk, 2 walk. 2 walks, and then we get home. And normally we walk to the left. We start over here in the positives and we walk left. However, what if we did -4 divided by 2?
Negative.
Then we would start at -4. And then we always walk towards home. We do 2 walks, but because we're going the wrong direction, the answer is -2. The opposite. You don't have to worry about the negatives that much, but it's very similar with negatives, except you just have to get the sign right at the end about whether you were doing negative or positive.
Okay, I don't think I was following.
Yeah, the important thing is just basically the positives, where
Okay.
like, so let's do 6 divided by 3. So on the number line, what do you do? Tell me what to draw.
Okay, so 6 divided by 3. So what are we doing? We start at like 6 or something.
Okay, start at 6.
And then it's in chunks of 3. So there's like 2 3s, which would mean you like go back 2 times for 3 miles each.
So 2 lines of length 3.
2 lines of 3.
That.
Yes.
Okay, and then what is the answer to the division problem?
So like, how many? Okay, so what is division? I think it's 2, but I'm trying to figure out why it's 2. Okay. So like, how many times can you subtract 3 from 6? You can do it 2 times.
Yep, or it's the number of walks to get home.
Hmm.
There were 2 walks, so it's 2.
2.
So
Let's
do one more of them. 3 divided by 1. What do we do?
3 divided by 1. So that would be 3 ones. Like 3 minus 3 minus 3 minus 3. It would be like 3 walks. Yeah.
What should I draw?
You go to the negative 3 times for 1.
Right, what should I like? Should I draw a dot? Should I draw a line?
No, should draw. Okay. You draw a line from 3 to 2, then you draw a line from 2 to 1, then 1 to 0.
Okay, yeah. Okay, makes sense?
Yeah, I think so. It seems like something I'd need to like think about more to very much understand and like have it memorized.
Yep, so very quickly, just so you know what it does. We'll do multiplication again. So 3 times 3 equals 3 plus 3 plus 3. Like, this makes sense? To add up 3's 3 times?
Yeah, like 3 threes. And that is 3 threes.
Okay, and then do you know what exponents are?
No. Uh,
Okay, well, in short, they're repeated multiplication. So this little symbol here is the exponent symbol, and 3 exponent 3 means 3 times 3 times 3. So it's a higher level version. Like, addition is multiplication is repeated addition, and then exponents are repeated multiplication.
can
Like
you have
a
like
fancier thing.
can you have repeated exponents? Can you go another level?
You could make that up, but it's not a standard thing. Like,
Okay, so
not
it's not a
normally
standard
used or
thing
useful.
that exists, but if you wanted to, you could just make it up and it's not too hard.
Yes, you will get big numbers really fast if you do that. Like really big
Hmm.
numbers.
Hmm.
Oh yeah, speaking of numbers, alright. The 10 equals. Why don't you try to estimate what this might be? Well, first tell me what is it in like regular.
Okay, 2.
So this, like this. What do I write?
Okay. So what is it? Okay, so what am I trying to figure out? Am I trying to figure out what it's like in multiplication?
Yeah.
Oh wait. First guess. 1024 is what the answer is. That's my first guess.
Okay, you're right, but
Okay. So that's because
you've just heard it before,
uh,
right?
I don't know. It's
You pick that
like
number up somewhere. People talk about it a lot.
it's like 2, 4, 8, 16, 32 repeated
Yes, that is the sequence.
exponents. Okay. What is it though?
Does this make sense? What I just wrote?
Hmm. Two. No.
So this one makes sense. Does this look similar?
Does that one look similar? Okay, so that is 3 to the power of 3. So is that like 3 times 3 3 times? Or
Yeah. Multiplying together 3 3s.
okay.
This one is multiplying together 10 2s.
Okay. Together. 10 twos. Okay. Huh. 30.
Anyway, you already knew 2 to the 10, so I just wanted to point out how the numbers get really big.
Yeah. So what would it be? Okay, so
Just make a wild guess. Like don't even worry about it.
1 billion.
Nope, it is a trillion.
Oh.
Wait, did I fuck up? Wait, 2 to the 10 is around 1,000. 1,000 times 1,000 is a million. Then times 1,000 again is about. Oh, never mind, you got it. I meant to do it so it'd be a trillion. 2 to the 40 is a trillion. So you got really big numbers. Like we have a 2 and a 4 and a 0, and somehow we have a trillion. It's more powerful than multiplication. Like using multiplication, we couldn't get that big that fast. We're like 2 times 40. And we're only at 80. Kinda sad. And even if we did like 999 times 999 equals. In order to get to a trillion, we have to write like. We have to write out like way more digits to get up there.
Yeah.
Okay, so what did we cover? Let's wrap up. How to put math in trees, and why the order of operations matters, and how to convert different math expressions into the tree, and how to do the math when it is a tree.
Tree. How to do the math when there's a tree. Yeah, those sound right. We did like the order of operations. I forget if you said that.
Yep.
Oh yeah, prefix, infix,
Yep.
and postfix.
Yep. So when you write normally in a line like this, it's hard to see what things are grouped together. Whereas when you have a tree, you can see the groups. Like this is a group, this is a group, group, group.
Mm-hmm.
But here we don't know what's grouped together. Like maybe these two are grouped. Or maybe like these three are grouped. Who knows? It doesn't tell you what the groups are. But you could sort of imagine different groups. Like you could write parentheses in different ways. You could write parentheses there. Or you could undo it and you could write parentheses there and be like, that's the grouping. So the tree always shows you like how things are grouped together, and then when you're writing like this, it doesn't. It's exactly the same with math. So math has two tools for dealing with that to tell you the grouping or which things go together first. And one of them is order of operations, and the other one is writing out parentheses to tell you groups. And the trees just have that built in, so instead of order operations and parentheses, you can see the grouping in the tree structure. There's a different way to show you the grouping that's generally clearer and easier to see. It has a very similar purpose. And English writing is also similar, where when you write out a sentence, it's not really just a bunch of stuff in order. It is really a tree where different things are grouped together in different ways, and there's parents and children. But how do you know, like, what words are parents and childs of what other words? There are two things to tell you. There are the rules of grammar, which are like order of operations, and there are punctuation marks, including literal parentheses, but also like commas, which are kind of similar. And thanks to grammar rules plus punctuation, you can take a sentence and turn it into a tree where you see what the groups are and how it fits together, which we're not going to do today, but that's like a preview of one of the ways this stuff works that's very similar to the math stuff. It works similarly with English sentences. Does that make sense as like a general concept?
Works similar with English sentences. They also have like some kind of tree thing which groups them together.
Yep.
That makes sense. It's not just like random stuff. Some things affect other things.
Yep.
Yeah.
Okay, any questions? Should we stop?
Questions? I don't know. I feel like I somewhat understood exponents. I just kind of forgot how they work, cause I what?
Yeah, those aren't too important. I just want to talk about them briefly because we did multiplication and division, and they're very similar.
Okay, I need to figure out more about like what is it called? Oh, yeah, thinking about it like repeated addition and repeated multiplication. Thinking about those things more, I think would help.
Yep. Okay, so was that fun? Too long? Too short?
I don't think it was too long. I don't think it was too short. I think it was fine. I think it was good.
Okay. End stream later?
Okay.